Hello, this lesson is on elasticity of demand. The question that we want to be able to answer is, how high can we drive up the price and still create increased revenue? Businesses often want to know how to generate increased revenue. Elasticity of demand is one method of analysis that a business can use to determine this information. When the price is going up and the revenue is going up, the demand is said to be inelastic, meaning when the price and the revenue are going in the same direction, increasing, demand or the quantity is inelastic. That means that even if the demand goes down, revenue prices go up, and revenue will continue to increase with small changes in price. So let me show you where that is on this graph here. So here, price is our input, our independent variable, and we know that revenue is equal to price times quantity, or RFP equals P times the demand equation. So here's price on the x-axis, and here's revenue on the y-axis. And right here, the price is increasing, and the revenue is increasing. And hiding behind is the graph is the quantity. And the quantity might be going down because less people drop out of the market when the price goes up. But even if the quantity goes down, the revenue is still going up. So as price increases, revenue increases. So that means the demand is inelastic. And its elasticity value is going to be E less than 1. So we're going to find out how to find the elasticity value. So when E is less than 1, the demand is said to be inelastic. Okay? When the price is going up and the revenue is going down, the demand is said to be elastic. Meaning, when the price and revenue are going in opposite directions, price up, revenue down, demand, or the quantity of demand, is elastic. The demand is definitely decreasing, and it's causing decreases in revenue because of the increase in price. So that is over here on this part of the graph. Here's my revenue function. And over on this side, price is going up and revenue is going down. And so the demand is said to be elastic. So that looks like number 3 here. You would say as price continues to increase, revenue is decreasing, therefore demand is said to be elastic because an increase in price lowers the revenue. And this function that we're going to write called the elasticity function will give you a value, and if it is greater than 1, then demand is elastic, and we're going to get decreases in revenue. Finally, when the demand is neither inelastic, like over here, nor elastic, like over here, it has reached what we call unit elasticity. And this is the price where the revenue is at its maximum because the price is at the optimum value. So this is number 2. At a happy value of price, revenue is maximized and unit elasticity is achieved. So we're going to learn how to write an elasticity function, and when it equals 1, you have found the perfect price and the maximum revenue. And so we will be goal seeking the elasticity to 1. It's the only time you ever goal seek to 1. And that's another way to find the maximum revenue. So we have learned about optimization. We know how to find the max revenue by taking the derivative of revenue and goal seeking it to 0. Well, now we can also take the elasticity function that we create and set it equal and goal seek it to 1 and find that same max revenue. Here is the elasticity function. In our calculus course, we use a function called the elasticity of demand function, or E of P, that allows us to calculate this E value using the demand function the derivative of the demand function, and the price. And the elasticity function is this. You have to have this memorized. It's E of P. So notice that P is going to be, price is going to be our input, equal to negative P times the derivative of the demand function divided by the original demand function. This simply reads the elasticity value is -1 times the price times the derivative of the demand function, all divided by the demand function. And this -1 is important. I would type out -1 times P to ensure that I didn't get any errors. So you'll be given a demand function, and you will take the derivative of demand, and you'll find the elasticity function. And we're going to use Excel to help us calculate it, but we need to be able to put this on paper, because I'm going to test you on that, being able to put this on paper, even though Excel is going to give us a little easier way to calculate the E value. We're going to find the derivative of the demand function and then use the derivative within our spreadsheet, and we'll access cells for P, D of P, and the derivative of P to input our elasticity function. It is the easiest method given the benefit of Excel, so make sure you learn how to use the Excel way. And then we're going to goal seek our elasticity function to 1 to find the unit elasticity, or the price to charge for maximum revenue. So let's look at an example. Go back to the very beginning. This is the sheets example. It says, this first one is just a general example about an electronic device. It says, suppose the demand function for a specific electronic device is D of P equals 58E to the -0.00912 P, where P is the price in dollars and D of P is the demand in thousands. So just like before, P is price and D of P is quantity, but it's our demand function. We want to know the demand at a price of 100, the revenue at a price of 100, the elasticity of demand function. We'll put in this blank. I'll put it on a sheet of paper in a minute. The elasticity at a price of 100, at what price is unit elasticity achieved, and if the business is presently charging 120 for the device, what would you advise them in order to increase their revenues? So let's find the elasticity function, and then we'll come back and do all these things. Okay, so here is our quantity of demand function, and we are going to write the elasticity function, which is -P times the derivative of the demand function over the demand function. So we need to find the derivative of this function, and so it's 58 times e to the -0.00912 p, and so 58 is a constant because it doesn't have a variable after it, so you can bring that 58 down. And then e to the -0.00912 p is an e function, and we'll have to use the chain rule. And so the derivative of e to this parentheses is simply e to this parentheses times the derivative of this power is -0.00912. So I'll write my e function at the end. So this is the chain rule. Constant comes down, derivative of the power is here, times the derivative of e to the parentheses is e to that parentheses. So that's our derivative of demand. And now e of p is equal to -P times 58 times -0.00912 times e to the -0.00912 p over e to the -0.00912 p, and I forgot the 58, over the original demand. So this is the original demand, and that's why I wrote it down here. Okay, now you may be wondering, can we cancel the 58 and the e? Please don't. I'm going to want you to demonstrate this unsimplified on your test paper or whatever I ask you to do. Okay, so now we'll come back and go back to type it in Excel. I'll show you a cool way to do that. Okay, so the cool way to type this into Excel is to always start with your input, which is P, and then type in the demand function, which is D of P, and then the derivative of the demand function, which is D prime of P, and then your elasticity function, which is E of P. And so you would type in the original demand function, which in this case is 58 times E, which is EXP, put the power in the parentheses, negative 0.00912 times P, close the parentheses, and then you type the derivative in, which is right here, 58 times negative 0.00912 times EXP, parentheses, negative 0.00912 times P. Just check that. And then here's how you do elasticity. So we know elasticity is negative P, right? Well, always type in a -1. So let's type in equals -1 times, and then you got the derivative P, so you just click on column C, and then divided by D of P, which is column B. So I will save that for you. Put it right here. Probably should hit enter first. Okay, so I got that fixed up, and I put what you type in here, and you'll just memorize that. So what we write on our paper is a lot different than how we type in the elasticity function in Excel. Okay, so now we can answer the questions. A, what is the demand at a price of 100? So P is our input, so if we put 100 in, then our demand is 23.2998 electronic devices, because remember, this is price. P stands for price, and that demand is really quantity. Okay, so then the second question, what is the revenue at a price of 100? And I don't have a revenue function, but it's very easy to build in Excel. Revenue is simply price times quantity. So the revenue is $2,329.98. We've already done the elasticity function right here. What is the elasticity at a price of 100? So okay, I had to pause the video because when I looked up here before I paused it, it was negative, and that told me that I had done something wrong, and I'd put the derivative in here from my little mess up over here. So now I have the right elasticity, -1 times the derivative, -1 times P times the derivative divided by demand. Okay, so now I can answer this question. What is the elasticity at a price of $100? And it is 0.912. So if you recall, when elasticity is less than 1, then the demand is inelastic. The quantity of demand is inelastic. That means that price is increasing and revenue is increasing when this demand, even if the quantity of demand is going down. So we have demand is inelastic here. Next question, at what price is unit elasticity achieved? Okay, so I'm going to just drag everything down, and what I'm going to do is goal seek elasticity to 1. It's the only time you goal seek to 1. That's what we mean by unit elasticity. So I'm going to goal seek elasticity to a value of 1 by changing my input, and I get a price of $109.65. And that's also max revenue. And then it says, if the business is presently charging $120 for the device, what would you advise them in order to increase their revenue? So let's drag this down one more time and put 120 in here. And as you can see, elasticity is now greater than 1, which means that the quantity of demand is elastic. That means they're losing customers and the revenue's going down. So you can see that revenue went down. And it makes sense if you're raising the price above what we just found is the perfect happy price. It would make sense that you would not have your max revenue anymore. So we would advise them to lower the price to $109.65. Okay, so our second example is the Sheets example. Sheets can sell cups of coffee in an hour based upon the following demand function: D of P equals negative P squared plus 45, where P is the price per cup of coffee and D of P is the number of cups per hour. A, find the elasticity of demand at a price of $2, $3, and $4 and interpret each of these values. And then second question, what is the price that gives Sheets the maximum revenue? So you would always be asked to write the elasticity function on paper, and so we'll do that. You try it, and then I'll have it posted up here in just a second. Okay, so hopefully you got E of P equals negative P times the derivative of the demand function, negative 2P, all over negative P squared plus 45. And I know that this is very easy to multiply together. Just leave it simplified, leave it just like this, because the way we do this in Excel is completely different. Remember what you do. There's P, there's D of P, there's the derivative of P, there's E of P, and you might add revenue if the question asks for it. And we want to know the elasticity at 2, 3, 4. And the main thing to remember here about this one, the demand function is negative P squared. And remember, Excel gives you a flat out error if you type this in the way it looks. You have to have understood negative 1 times P squared plus 45. And then the derivative is negative 2 times P. And then E of P is equal to negative P, so negative 1 times the P column times the derivative column divided by the demand column. We'll drag this down. I have a positive E value. That means I didn't make a mistake. This derivative is very, very easy. Usually it's going to be more like this one where the derivative is tricky, and so it's easier said than done. But if you get a negative elasticity, it usually means that you've taken a derivative wrong. Anyway, to answer this question, find the elasticity of demand at a price of $2, $3, and $4 and interpret each of the values. Well, this one is less than 1, so demand is inelastic. This one is less than 1, so demand again is elastic. This one is greater than 1, so demand is elastic. Do you remember what that means? It means that at $2, small increases in price are going to increase the revenue, because we're on this part of that parabola example. So we can continue to increase the price is what this means. So if your demand is inelastic, then you could say something like small increases in price from $2 will increase revenue even if quantity of demand goes down. And same thing for $3, since the elasticity at $3 is less than 1. Small increases in price from $3 is going to increase your revenue, even if the quantity of demand goes down. However, if you charge $4, then you've got elasticity. The quantity of demand is elastic. That means revenue is going down. So you could say something like, at a price of $4, revenue is not at its maximum, and the price should be lowered. Something like that. And then it says, what is the price that gives Sheets the maximum revenue? So that means goal seek, but we know it's somewhere between 3 and 4 because it's inelastic at 3 and elastic at 4. So we would goal seek to 1. We don't need the revenue function. We've got the elasticity function, but we goal seek the elasticity function to 1. And there it is. It's close enough. That's Excel's tolerance levels. So we find out that we should charge $3.87 for a cup of coffee to maximize revenue. And I'll go ahead and mention now, go ahead and do all of these elasticity problems and check the key. And for the discussion question this week, you are going to be asked to write a elasticity question. And what that means is be creative, come up with something that you want to sell, and come up with a demand function. It can be an E function, a quadratic function. Number 1 is a nice linear function. Number 2, the demand function, is an E function. But the thing is you have to come up with reasonable answers. So you have to make the problem and then come up with find the answers so that it works out. This is a square root function. This is a polynomial quadratic. So there's a lot of things. This one you would use the quotient rule. So try your hand at coming up with, this one's talking about plants. Number 6 is talking about a gallon of milk. Number 4 is talking about barrels of oil, so forth and so on. So create an elasticity word problem and type it into the discussion board and make sure that you found your answer and that the answers are reasonable. Don't post the answer though. Okay, I wanted to do one more example with you. Number 2 in the lab manual, a bakery determines that the number of chocolate chip cookies sold daily at a price per cookie P in dollars is given by this function. We have to create the elasticity function. And I wanted to go over how you answer questions like B and C over what range of prices is the elasticity of demand elastic and inelastic. And then I also wanted to review how you create a revenue function because you need a maximum revenue function. So I'm going to do those things on paper and then come back to Excel. Okay, so the first thing we notice is that P is my input, price, and Q is my output, and Q stands for quantity. So this is a demand function, D of P equals Q. And so the first thing we need to do is take the derivative of this. So it's a lot like the other one. You don't need to use the product rule because this is just a constant, 96.7. So I'm going to bring it down. And then to take the derivative of this E function, I'm going to take the derivative of the power, and then the derivative of e to this power is e to this power. And then plus, so we can look at this, the derivative of this constant 3.3 is 0. So this is the derivative, 96.7 times negative 0.25 e to the negative 0.25p. So we're going to need that, and now we can write down our elasticity function, which is negative p times the derivative, which is 96.7 times negative 0.25 times e to the negative 0.25p, all over the original demand function, which is 96.7 e to the negative 0.25p plus 3.3. So that's our elasticity function. I would prefer you not to simplify it. That's just what you write on your paper. We're going to calculate it differently in Excel. And before I leave my paper, I wanted to remind you how you build a revenue function. So we know revenue is price times quantity. And remember, once you decide that P is your input, P is going to stay your input. So we're going to build an R of P function. And we know revenue is price times quantity. Well, if I know my P's input, this has to go away. So I'm going to substitute this in for my P. So that's R of P is equal to P times 96.7 e to the negative 0.25p plus 3.3. And we could use Excel to build this, but I just wanted to review that with you. Okay, so we'll go back to Excel now. Okay, we're talking about chocolate chip cookies, and we have already stated the elasticity function, and now we need to find what range of prices the elasticity of demand is elastic and inelastic. So what that means is we're just going to put in our typical P, and then demand of P, which is Q, derivative of P, E of P, and if you remember, we are going to be asked about revenue. Okay, so I'm going to type in the demand, which is 96.7 times EXP parentheses negative 0.25 times P plus 3.3. And then the derivative, which is equals 96.7 times negative 0.25 times EXP times negative 0.25 times P okay, and then my E of P, I don't type in what I wrote down. I type in equals negative 1 times P times the derivative of the demand divided by the demand function. And then my revenue, I reminded you how to build it. That's in case you need to take a derivative later. But with Excel, I can just remember that revenue is price times quantity. And I want to know the range of prices. So I want to maybe look at some prices. You could just find the max revenue. But I'm going to do what we normally would think to do, and that is to put in sort of a range, or put in a domain. So we're talking about cookies. So I'm going to look at cookies in 25-cent increments, cookie prices. And my elasticity is inelastic, so I'm going to keep going. It's still inelastic. And then it starts to be elastic, which means that somewhere in between 425 and 450 is my max revenue. So I'm going to insert, and I'm going to find the max revenue, or the perfect price. So remember, what we're going to do is we are going to goal seek elasticity to 1. There it is, 441 is our elasticity price. Now, the reason I'm going over this is because people miss this question all the time. Over what range of prices is the demand elastic? Which sometimes people look at the domain they created and they say from 450 to 550. Well, that's not really the answer to the question. What we should be saying is it doesn't matter what we typed in for the domain. What matters is where unit elasticity is, and I really want you to get this right this time. So I'm going over it. Never have gone over it before. The unit elasticity occurs when the price is $4.41, right? So any price greater than 441 is going to create elasticity. The demand will become elastic. So instead of writing particular numbers, the answer to the question over what range of prices, you would say any price greater than $4.41 will make demand elastic. In other words, anything greater than 441 is going to cause the revenue to go down. Okay. Any price, not specific prices. Don't look at these and write these down on your paper. That's what I'm trying to say. Same thing for this next question. It says, over what range of prices is the elasticity of demand inelastic? And that would be any price less than $4.41 is going to make the demand elastic. Okay, so if it's asking for a range of prices, find the unit elasticity price, and anything less than that is going to be inelastic, and anything greater than that price would be elastic. The next question, we've already done it. That's, I think, also the tricky part. What price should the bakery charge in order to have maximum revenue? Well, we found it. It's $4.41. And what is the maximum revenue? When we anticipated that, we put the revenue function in. So that would be $156.15. And then the next question, if the cookie price is $4 per cookie, will a small increase in price cause the total revenue to increase or decrease? Well, it's less than the perfect price. So if you increase the price at $4, it's going to cause revenue to increase. Remember that quad graph. They're not all going to look perfectly quadratic, but that example here just sort of registers in my brain. When you have some elasticity less than 1, small increases in price are going to cause an increase in revenue till you get to the max revenue and the perfect happy price. Then increases in price is going to cause revenue to go down. Okay, so I think that's enough. Again, do all these lab manual problems, check the key. I have answers in here, and I've typed in the elasticity function. So when you're doing these problems, be thinking about what kind of items can I sell and write a demand function for my discussion question.